Hey y'all, in this video, I'm going to be talking about energy and how that affects phase changes of our states of matter. So, phase just means state. So, a phase of matter is a state of matter. Okay, so try not to get too confused with that new vocabulary there. So, one of the things that you may be familiar with is how temperature affects different phases of matter. If you add heat to a solid, eventually it will melt into a liquid, and then that liquid will turn into a gas. So, thinking about like water and thinking about ice, when we add heat to ice, which is solid water, it turns into a liquid. And then adding more heat to that liquid will eventually turn that water into water vapor. Okay, so temperature means that kinetic energy is increasing. We've talked about how temperature also increases the motions of these particles. And so these particles are going to kind of bounce around until eventually they start moving away from each other and then go into a different phase. So again, solids to liquids and liquids to gas. However, there is an opposite force that is also working against kind of this temperature change, and that's pressure. And so pressure on particles, which is just this force again acting upon it. We think about like high air pressure, it feels like you're being pushed down. The same things are happening with our particles. And so pressure is causing the space between particles to decrease. And if we put enough pressure on gas, that gas will condense into a liquid. And then if we keep putting pressure on that liquid, it will condense into a solid. Okay, so there's two different things that are affecting our states of matter, and that's temperature and pressure. Now, you're probably pretty familiar with the name of some of these phase changes. We have the special vocabulary from going from a gas to a liquid and vice versa. And you should be pretty familiar with those as well as liquid to solids. The two new ones you'll probably be learning today is gas to solid and solid to gas, and we'll get there, okay? So, our gas, sorry, going from a liquid to a gas, of course, is called evaporation. So, when liquid water sits on the table and then eventually turns into a gas, it is called evaporation. Going from a gas to a liquid is condensation. So we saw that with the video of the condensation happening on the glass. There was water vapor that was turning into a liquid on the outside of a cold glass. Okay, liquid to solid, of course, solid to liquid is melting, and then liquid to solid is freezing. Okay, so again, we're pretty familiar with those terms. Now, the new ones here, solid to gas is called sublimation, and then gas to solid is called deposition. And sublimation, again, happens when solids go directly to gases. You can see this happen if you've left ice cubes in the freezer for a really long time. Your ice cubes will start getting smaller and smaller, and that's because sublimation is happening. There's this solid being turned into a gas. Deposition happens on like frosty windshields. So windshields that get ice on them overnight is because you've got this really cold water vapor that is now solidifying into a solid on top of the windshields, and it's depositing ice, right? So deposition there. So last thing I want to talk about is something that's called a energy it's a phase. So last thing I want to talk about is something that's called a phase diagram. And so here we've got pressure on our y-axis, and so as we go up, pressure increases. And then we also got temperature here on the x-axis. So as we go to the right, temperature increases. Okay. And so we can see some trends, and you're going to see these general trends in all phase diagrams. So where there is low temperature and high pressure, we've got solids. Okay. So again, low temperature means there's not as much kinetic energy in our particles, and high pressure means that the space between our particles is decreasing. So less energy and less space means we're going to be in a solid. Okay. And then at high temperatures and low pressures, you're going to see this gas vapor or this gaseous state or vaporous state here. And again, high temperature means lots of particle motion. Low pressure means lots of space between our particles. So that's going to allow a gas to exist. And then somewhere in between is this liquid phase. Okay, so it exists kind of in that middling phase between temperature and pressure. One of the things about this phase diagram that I want to point out to you is this area right here. It is actually labeled T. This T is called a triple point. So the triple point is where all three states of matter or phases exists. Okay, so triple point is where all three states of matter exist. So at this exact temperature and pressure, you can find a solid, liquid, and gas of this specific substance. C is our critical point. Critical. Pardon my horrible writing with my trackpad here. And what's interesting about this area is we start seeing kind of this weird like semi-gas liquid phase. Our phases start to get really, really jumbled after this kind of temperature and pressure. And we start really seeing just kind of weird things happen. So we don't really see our normal solid liquids and gases after kind of our critical point here. Okay. That's it.